Hello everyone, I am Vijay from Vijay Maths Academy. Welcome you guys. I hope in the last class we discussed regarding the brief introduction of polynomial and its types. Just I will recall once again. So what are actually the types? So polynomial is denoted by p of x, polynomial in terms of x, that is polynomial in terms of x we will denote, whereas so what is a here polynomial in terms of x, what is x here? X will be the variable, x will be the variable. So what are the types we discussed in the last class? First one will be the linear, second one will be the quadratic, second one will be the quadratic, third one will be the cubic one, third one will be the cubic one. Linear means polynomial whose degree is 1, quadratic means whose degree is 2, cubic means whose degree will be 3. I hope it is very clear to all the students. If you are not aware, please go through the first video and follow it. So now in this class we will discuss regarding the general form of polynomials. General form of polynomials. For the linear we have one general form. For the quadratic we have one more general form. Likewise we will see first one, linear polynomial. Linear polynomial. So linear polynomial means whose degree will be 1. Whose degree will be 1. Degree of variable x will be 1. Then it is a linear. So for this the general form will be p of x is equals to ax plus b. Ax plus b. We saw the many examples like x plus 1, x plus 5, x plus 7, x minus 8. These all are the examples for linear. But this is the actual general form for the linear polynomial. So here a will be the coefficient of x, whereas b is the constant term. So a will be coefficient of x, b will be the constant term. Dear students, so you might have little bit doubt regarding what is actually the coefficient. Suppose I will give one best example for you guys to understand. Suppose this is a Bablu and this is a his friend Motu. These are both friends. So he will be Bablu, he will be Motu. So beside the Motu, who will be sitting? Beside the Motu, Bablu will be sitting. In the same way, beside x, what will be there? It will be a. So here coefficient of x will be a, whereas b will be the constant term. B will be the constant term. So you people will very clearly understand regarding the coefficients and constant. So linear polynomial, the general form will be ax plus b. Okay, where a is a real number and which is not equals to 0. Next we will go through the second type, that is quadratic polynomial. Quadratic polynomial, already you people will be might thinking about what is actually quadratic means. In mind the one thing will comes, the degree will be 2. Degree will be 2. Quadratic polynomial. Quadratic polynomial. Okay. and here degree will be degree will be 2. Now you should frame your own examples for the quadratic polynomial, but I suggest that the general form general form for the quadratic equation will be p of x is equals to ax square plus bx plus c, whereas a is not equals to 0. A comma b comma c are the real numbers are the real numbers. So here for the quadratic highest degree will be 2. The general form will be ax square plus bx plus c. Now you can compare. So what will be the c, what will be the b, what will be a? I will tell very clearly. Is there any variable here? No, not at all also. There is no variable means this is a constant term. So behind the x, b will be there. This is called coefficient of x. Behind the x square, we have a constant a, that is coefficient of x square. Coefficient of x square. Okay. Is it clear for you guys? Okay. We will move on to the next third type, that is cubic polynomial. So you people should enjoy the learning also, because these topics are very easy and most important from the point of examination. Next, third one will be cubic polynomial. Cubic polynomial. See how the guys are very enjoying the learning. They are might thinking that cubic means the power of x will be 3. Here degree of x will be 3. Now I will give the general form. P of x is equals to a x cube plus bx square plus cx plus d, whereas a not equals to 0, a comma b comma c and d are real numbers. Now in the same pattern you should differentiate the coefficients. So what will be d here? D is a constant term. What is c here? C will be the coefficient of x. What will be the b? B will be the coefficient of x square. What will be the a? A will be the coefficient of x cube. One more time, you should remember that for the linear we have two terms, ax plus b. For the quadratic you should have the three terms, ax square plus bx plus c. For the cubic you should have the four terms. This is 1 2 3 4. So ax cube plus bx square plus cx plus d, where a is not equal to 0. And also some people are getting little bit some ideas, new thoughts, like why sir will be taking a not equals to 0. So what will happen if a is becomes 0? Now I will tell. Suppose I will take quadratic polynomial, that is a x square plus b x plus c is a quadratic polynomial. Now you are telling that suppose a becomes, we will actually telling a not equals to 0, but you guys are thinking that if a equals to 0 what will happen? What will happen means wherever a is there you have to put the value a, so this becomes 0 b x plus c, so only this will come. So what will suggest, when a becomes 0 it goes to the next level of polynomial. If quadratic, if a is 0 it becomes linear. If it is cubic, if it is 0 a it becomes quadratic. In like this you have to remember. Next, next one will be the value of p of x. Value of p of x at x. Could take some examples. Now, I will take one example, that is x plus 5. So this is p of x is equals to 5. I will suggest put x is equals to 1. Put x equals to 1. Now here p of 1. So what will comes 1 plus 5. So this is the value of p of 1 at x is equals to 1. In general, in general, in general, we will take it as a k. It as a k. It as k. When the instead of x we will put k, then we will call as the value of x at x is equals to k. Next, I will take one more example, that is p of x is equals to x minus 5. X minus 5. So what type of polynomial this is? This is a linear polynomial. Now I suggest to put x is equals to plus 5. Now p of 5 is equals to 5 minus 5. You will get 0. You will get 0. See, when you are putting the value of x is equals to 5, you are getting 0, means this is actually the solution of this polynomial, that is called zeros of a polynomial. Zeros of a polynomial. So one more time I will explain with other example. Other example I will take. Okay, so x minus 1 or x plus 1 I will take. So p of x is equals to x plus 1 means put any values. You should get the p of x would be 0. So now I will here put x is equals to minus 1. P of minus 1 is equals to minus 1 plus 1. So minus 1 plus 1 minus subtracting 1 from 1. So it will get 0. So here also we are getting 0, means this is called 0 of p of x at x is equals to minus 1. P of x at x is equals to minus 1. Next, one more thing I should tell here, zeros of a polynomials. Zeros of a polynomials. For the linear, for the linear polynomial, for the linear polynomial. So our polynomial is ax plus b. When it becomes 0, take ax is equals to minus b. How it comes minus? When the left side hand side term is going to right side, this becomes sign will be changes. Now here a is in terms of multiplication, so x is equals to minus b divided by a minus b divided by a. One more thing is we have to make one relation also. So minus b here is what? Minus constant term, minus constant term divided by a means what? Coefficient of x. Coefficient of x. Now I will take one example to show the linear polynomial. So I hope it is very clear, you all of you understanding. Okay na? Okay, suppose 5x plus 1 is a polynomial. We have to make equal to 0. 5x is equals to minus 1, x is equals to minus 1 by 5. So this is the 0 of the required polynomial. 0 of the required polynomial. Okay, next, For the quadratic, for the quadratic, the equation will be ax square plus bx plus c. This is a quadratic polynomial. For this, see, highest power will be 2, means we have the two zeros. We have the two zeros. In general, we will take that is zeros will be denoted as one is alpha, other one will be beta. These are two zeros. Okay. Now, one more thing I have to tell, that for the linear x plus 1, the graph will get only linear. This is a linear graph. This is x, this is x dash, this is y, this is y dash. Somewhere you will get a one point. This is a linear. This is a linear. Next, quadratic. So here I will take one example to show you. X square plus 2x plus 1. How many times the graph will cuts the x-axis, that you have to see. Now x square plus x plus x plus 1 make pairs. So here you take x as common, x plus 1. Here you take 1 as common, x plus 1. Make equal to 0. X plus 1 is equals to 0. X plus 1 is equals to 0. X is equals to minus 1. X is equals to minus 1. How many values we got? We got the two values. So these are the required zeros. So x is equals to minus 1, minus 1. These are the required zeros. These are the required zeros. It may have one zero, it may have no zero also, but it should not cross the maximum 2. It should not cross the maximum 2. For the linear we have one zero. For the quadratic maximum we have two zeros. Next, we'll go through the cubic. Now I will take one graph to show you guys. Okay, na? Okay. So this is the graph. Cartesian plane we called as Cartesian plane. This is y dash. See, see, graph already you are looking here. This is the center, that is called origin. See how many times the curve cuts the x-axis. This is the one point, this is the second point, this is the third point. We should not consider the y-axis because this is only one variable. So x-axis cuts three times. So cubic polynomial has a maximum three zeros. Either it may be 2, either it may be 1, either it may be 0, but it should not cross the maximum three zeros. So what we learned in this class means types of polynomials and their general form. Types of polynomials and their general form, along with some examples, and also we find out the zeros. Okay. And guys, if you have any doubt regarding this class, the comment box will be always open for you. Just put a comment in the comment box and ask any queries. So by this we will conclude our today's class. We will discuss in the later. Okay, thank you.